Hello students, this is the example I didn't get to in class today, and it's on function notation. There's also some more examples in your book, so don't forget to look there if you feel like you need a little bit more after this short video. Alright, so looking at an equation, y equals 2x plus 3. That's a linear equation, as you will learn a little bit earlier on. It's also a function. For every x, there is only one y. Okay, so another way to write this, the same way to write the same thing, and the notation that is used when you get on into high school mathematics is f of x equals 2x plus 3. Now be careful, this is not f times x. This means we say it f of x, and what it means is the function at any value of x is equal to 2x plus 3. So take a little time to absorb that. We're really saying that we can take y, our output, and we can replace it with this expression f of x, meaning the function for any input x is equal to 2 times that input x plus 3. Okay, so let's look at this function f of x equals 2x plus 3, and let's evaluate it for some values of x. So if you are told to evaluate for x equals 1, x equals 3, and x equals negative 5, here's what that looks like. We say f of 1, meaning the function for the x value of 1 equals 2 times 1 plus 3, which equals 2 plus 3, or 5. So f of 1 equals 5. It's another way of saying y equals 5. Alrighty, let's try for x equals 3. F of 3 equals 2 times 3 plus 3. Again, we're saying the function for an x value of 3 equals 2 times 3 plus 3, which is 6 plus 3, which is 9. So we can say f of 3 equals 9. And let's do the last one. F of negative 5 equals 2 times negative 5 plus 3 equals negative 10 plus 3, which is negative 7, or f of negative 5 equals negative 7. Okay, so I'm hoping you get a little bit of sense here. It's like we're replacing y with f of x. In other words, our input is x, our output is the function at any value of x, or f of x is our output. Let's try another one. Okay, thinking back to absolute value, let's try f of x equals 2 times the absolute value of x minus 1. This is a function. So the function for any value of x is 2 times the absolute value of x minus 1. So let's evaluate it for x equals negative 2, x equals 3, and x equals negative 5. Okay, so let's try f of the function at an x value of negative 2 is equal to 2 times the absolute value of negative 2 minus 1, which is 2 times the absolute value of negative 2 is 2, minus 1, which is 4, minus 1, which is 3. Let's try f of the function at an x value of 3 equals 2 times the absolute value of 3 minus 1, which is 2 times 3, which is 6 minus 1, which is 5. And let's try f of the function at x equals negative 5. I'll do one more just for fun. If you've understood this, you can go on, but I'll do one more. F of x equals 2x squared plus 3. Alright, so we're going to evaluate for x equals 2, x equals negative 3, and x equals negative 5. Okay, so let's get started here. f of 2, the function at an x value of 2, equals 2 times 2 squared plus 3. 2 squared is 4. 2 times 4 is 8, plus 3 is 11. And let's try the function at x equals negative 3, or f of negative 3, is 2 times negative 3 squared plus 3. Notice how I'm showing all my work here and putting my negative in parentheses. 2 times 9, which is 18, plus 3 equals 21. And lastly, f of negative 5 equals 2 times negative 5 squared plus 3. Negative 5 squared is 25 times 2, which is 50, plus 3 equals 53. So just to sum up, f of x equals 2x plus 3. F of x really is the same thing as saying y equals 2x plus 3, because f of x is my output, the function for any value of x, and it would be the same thing as saying y equals. Okay, we'll talk about this more tomorrow and answer any questions that you have.